The rating of the switch depends on the rating of the lighting transformer it is operating. For a small low-voltage lighting transformer, the switch rating should be at least equal to the transformer's secondary current rating. For example, if the transformer's secondary current rating is 2 amps, the switch rating should be 2 amps or higher. For a large transformer, the switch rating should be based on the transformer's primary current rating. For example, if the transformer's primary current rating is 10 amps, the switch rating should be 10 amps or higher. In general, a switch operating a lighting transformer should be rated for at least the maximum current that the transformer can draw. This ensures that the switch can safely handle the load and prevent overheating or damage. If the lighting transformer is small and has a secondary current rating of 2 amps or less, a switch rated for 1.5 amps, 2 amps, or 2.5 amps would be suitable. If the lighting transformer is large and has a primary current rating of 10 amps or more, a switch rated for 3 amps or higher would be required. Without more information about the specific transformer being used, it is difficult to determine the exact rating of the switch required. When selecting a switch for a lighting transformer, several factors need to be considered to ensure safe and reliable operation. These factors include firstly the transformer's voltage and current ratings, secondly the type of load being switched, and thirdly the environmental conditions in which the switch will be used. Transformers have both a primary and a secondary voltage and current rating. The primary side is where the power enters the transformer, and the secondary side is where the power exits to the load. The switch must be rated to handle both the voltage and current on the side of the transformer it is switching, typically the primary side. The current rating of the switch is particularly important, as exceeding this rating can lead to overheating and failure of the switch. Different types of loads, such as incandescent lighting, fluorescent lighting, and LED lighting, have different current characteristics. Incandescent lighting has a high inrush current when it is first turned on, which can be several times the normal operating current. Fluorescent lighting and LED lighting also have inrush currents, although they are typically not as high as incandescent lighting. The switch must be able to handle the inrush current of the load without being damaged. The environmental conditions in which the switch will be used can also affect its performance and lifespan. For example, switches used in damp or corrosive environments must be specifically rated for those conditions. Temperature is also a factor, as switches may have different current ratings at different temperatures. It is important to choose a switch that is rated for the expected operating temperature range. Here are some specific considerations for different types of lighting transformers. Firstly, for small low-voltage lighting transformers, these transformers are commonly used for landscape lighting, accent lighting, and other low-voltage applications. The secondary voltage is typically 12 volts or 24 volts, and the current rating is relatively low. A standard light switch with a rating of 15 amps at 120 volts may be sufficient for switching the primary side of a small low-voltage lighting transformer. However, it is always a good idea to check the transformer's specifications to ensure that the switch is adequately rated. Secondly, for large transformers used for commercial or industrial lighting, these transformers are typically used to step down high voltage power to a lower voltage for lighting. The primary voltage can be 480 volts, 277 volts, or other high voltages, and the current rating can be significant. A heavy-duty switch specifically rated for the voltage and current of the transformer is required. These switches are often enclosed in a metal box and may have features such as a disconnect handle and a padlockable mechanism for safety. Thirdly, for electronic transformers used for LED lighting, electronic transformers, also known as LED drivers, are used to convert AC power to DC power for LED lighting. These transformers can have complex current characteristics, and it is important to choose a switch that is specifically designed for use with electronic transformers. Some electronic transformers have a high inrush current, and the switch must be able to handle this inrush current without being damaged. Additionally, some electronic transformers have a minimum load requirement, and the switch must be able to provide this minimum load. In addition to the above factors, it is also important to consider the National Electrical Code, or NEC, requirements for switches. The NEC contains specific requirements for the installation and use of switches, including requirements for the type of switch, the location of the switch, and the wiring of the switch. It is important to follow all NEC requirements to ensure that the installation is safe and code compliant. When selecting a switch for a lighting transformer, it is always a good idea to consult with a qualified electrician to ensure that the switch is properly rated and installed. An electrician can assess the specific application and recommend the appropriate switch based on the transformer's voltage and current ratings, the type of load being switched, the environmental conditions, and the NEC requirement. Choosing the correct switch rating is essential for the safe and reliable operation of lighting transformers. By considering the factors discussed above and consulting with a qualified electrician, one can ensure that the installation is safe, code compliant, and performs as expected. Let's delve into some specific examples to illustrate the importance of selecting the correct switch rating for lighting transformers. Firstly, consider a small low-voltage landscape lighting system using a transformer with a 120-volt primary and a 12-volt secondary, rated for 200 watts. To determine the primary current, we can use the formula power equals voltage times current, or P equals V times I. Rearranging the formula to solve for current, we get I equals P divided by V. In this case, a primary current is 200 watts divided by 120 volts, which equals approximately 1.67 amps. A standard 15 amp light switch would be suitable for this application, as it exceeds the calculated primary current. Secondly, let's examine a larger commercial lighting system using a 480 volt to 120 volt step-down transformer, rated for 10 kilovolt amps, or kV amps. Again, using the formula I equals P divided by V, we can calculate the primary current. In this case, the primary current is 10,000 volt amps divided by 480 volts, which equals approximately 20.83 amps. A standard 15 amp light switch would not be suitable for this application, as it is significantly underrated. A heavy-duty switch with a rating of at least 25 amps at 480 volts would be required to safely handle the load. Thirdly, consider an LED lighting system using an electronic transformer, also known as an LED driver, with a 120 volt input and a 24 volt DC output rated for 100 watts. These LED drivers often have a high inrush current when they are first turned on. The inrush current can be several times the normal operating current and can damage an underrated switch. To determine the appropriate switch rating, it is important to consult the LED driver's specifications. The specifications will typically list the inrush current rating. A switch that is specifically designed for use with electronic transformers and that can handle the inrush current is recommended. It is also crucial to understand the different types of switches available and their suitability for different applications. Firstly, single-pole switches are the most common type of switch and are used to control a single circuit from a single location. They are typically rated for 15 amps at 120 volts and are suitable for many residential lighting applications. Secondly, three-way switches are used to control a single circuit from two different locations. They are commonly used in hallways, stairwells, and other areas where it is convenient to be able to turn the lights on and off from multiple locations. Thirdly, dimmer switches are used to control the brightness of lights. They are available in a variety of styles and ratings and are suitable for use with incandescent, halogen, and LED lighting. Fourthly, heavy-duty switches are designed for use in commercial and industrial applications where high current loads are present. They are typically rated for 20 amps, 30 amps, or higher and are enclosed in a metal box for protection. Fifthly, smart switches are electronic switches that can be controlled remotely using a smartphone, tablet, or other device. They often have features such as dimming, scheduling, and energy monitoring. Smart switches can be used with a variety of lighting types, including incandescent, halogen, LED, and fluorescent. When installing a switch for a lighting transformer, it is important to follow all NEC requirements. These requirements cover various aspects of the installation, including firstly, the location of the switch. The switch must be located in a readily accessible location and must be installed in a box or enclosure. Secondly, the wiring of the switch. The wiring must be properly sized for the current rating of the switch and must be installed in accordance with the NEC requirements. Thirdly, the grounding of the switch. The switch must be properly grounded to prevent electrical shock. Fourthly, the labeling of the switch. The switch must be clearly labeled to indicate its function. Finally, the inspection of the switch. The installation must be inspected by a qualified electrician to ensure that it is safe and code compliant. In addition to the NEC requirements, there are also some best practices that should be followed when installing a switch for a lighting transformer. Firstly, always turn off the power to the circuit before working on the switch. This will help to prevent electrical shock. Secondly, use a voltage tester to verify that the power is off before touching any wires. Thirdly, carefully strip the insulation from the wires, being careful not to nick or damage the conductors. Fourthly, securely connect the wires to the switch terminals, ensuring that the connections are tight and properly insulated. Fifthly, carefully mount the switch in the box or enclosure, ensuring that it is securely fastened and that the cover plate is properly installed. Sixthly, test the switch to ensure that it is working properly before restoring power to the circuit. Understanding the different types of transformers and their applications can further aid in selecting the appropriate switch. Firstly, step-down transformers are the most common type of transformer and are used to reduce the voltage from a higher voltage to a lower voltage. They are commonly used to step down high voltage power from the utility grid to a lower voltage for use in homes and businesses. Secondly, step-up transformers are used to increase the voltage from a lower voltage to a higher voltage. They are commonly used in power plants to step up the voltage for transmission over long distances. Thirdly, isolation transformers are used to isolate two circuits from each other. They are commonly used in sensitive electronic equipment to protect against voltage surges and noise. Fourthly, auto transformers are a type of transformer that uses a single winding for both the primary and secondary circuits. They are smaller and less expensive than traditional transformers but do not provide electrical isolation. Fifthly, buck-boost transformers are used to slightly increase or decrease the voltage. They are commonly used to correct voltage fluctuations. The physical location of the transformer and switch also plays a role in safety and compliance. Firstly, indoor locations are generally preferred for transformers and switches, as they are protected from the elements. However, indoor locations must be well ventilated to prevent overheating. Secondly, outdoor locations are acceptable for transformers and switches that are specifically designed for outdoor use. Outdoor equipment must be protected from rain, snow, and other environmental factors. Thirdly, damp locations, such as bathrooms and kitchens, require switches and transformers that are rated for damp locations. These devices are designed to resist moisture and corrosion. Fourthly, hazardous locations, such as areas where flammable materials are present, require switches and transformers that are specifically rated for hazardous locations. These devices are designed to prevent explosions. In summary, selecting the correct switch rating for a lighting transformer is a critical task that requires careful consideration of several factors. These factors include the transformer's voltage and current ratings, the type of load being switched, the environmental conditions, the NEC requirements, and the type of switch being used. By taking all of these factors into account and consulting with a qualified electrician, one can ensure that the installation is safe, code compliant, and performs as expected. Always prioritize safety and adhere to electrical codes and regulations when working with electrical systems. If unsure, consult with a qualified electrician. To further elaborate on the practical considerations for switch selection, let's discuss a few more aspects. Firstly, the inrush current handling capability is an essential parameter. When a transformer is energized, it can draw a significantly higher current than its steady-state operating current. This is known as inrush current. The switch must be able to withstand this inrush current without damage to its contacts or internal components. Switches designed for inductive loads, such as transformers, typically have higher inrush current ratings. Secondly, the rating of switches in enclosed spaces is important. The current carrying capacity of a switch is typically specified under certain ambient temperature conditions. When a switch is installed in an enclosed space, such as a panel or enclosure, the ambient temperature can rise due to heat generated by the switch and other components. This can reduce the switch's current carrying capacity. To account for this, it is necessary to direct the switch's current rating based on the expected ambient temperature. The rating factors are typically provided by the switch manufacturer. Thirdly, the voltage drop across the switch contacts is a consideration. When current flows through a switch, there will be a small voltage drop across the switch contacts. This voltage drop can affect the performance of the connected load, especially in low voltage applications. Switches with low contact resistance will have low voltage drops. Fourthly, the switch's endurance and lifespan are important factors. The endurance of a switch refers to its ability to withstand repeated switching operations without failure. The lifespan of a switch refers to the total number of switching operations it can perform before it needs to be replaced. Switches with higher endurance and lifespan will provide more reliable performance and reduce maintenance costs. Fifthly, the availability of accessories and features should be considered. Some switches are available with accessories such as pilot lights, which indicate the switch's status, and auxiliary contacts, which can be used to control other circuits. The availability of these accessories can enhance the functionality and flexibility of the switch. Choosing a switch from a reputable manufacturer can ensure quality and reliability. Reputable manufacturers typically offer comprehensive product specifications, technical support, and warranties. It is also advisable to check online reviews and ratings to get feedback from other users. Furthermore, consider the environmental conditions where the switch will be installed. If the switch will be exposed to moisture, dust, or corrosive substances, it is necessary to choose a switch that is specifically rated for those conditions. Switches with NEMA ratings such as NEMA 4 or NEMA 4X are designed to withstand harsh environmental conditions. In addition to the electrical ratings and environmental considerations, the physical size and mounting requirements of the switch are also important. Ensure that the switch will fit properly in the available space and that it can be easily mounted and wired. Finally, remember to always consult the manufacturer's instructions and specifications before installing or using any switch. The manufacturer's instructions will provide detailed information on the switch's ratings, installation procedures, and safety precautions. By carefully considering all of these factors, one can select the appropriate switch for a lighting transformer application and ensure safe, reliable, and code-compliant operation.